Next award, now the thesis award with master and PhD thesis. The award is sponsored by Hilti. Thank you. And two selected candidates will have 180 seconds to present their work. So 3 minutes. The winner of the 2025 thesis competition in the category master is Mr. Pentila, who is Mr. Pentila is research scientist at VTT Technical Research Center of Finland. His research covers variety of materials in the field of powder metallurgy with close ties to cemented carbides. His academic background is in material engineering with additional studies in sustainable materials and machine design. Please, you have the floor. 3 minutes. That's the challenge of the day.
Thank you. Hi, everyone. First, I would like to thank the EPMA, Hilti, and other partners for this recognition. It's an honor to be here today receiving this award, and I'm grateful that the months of work put into this gets this kind of attention. Next, I will have just a few slides about the contents of my thesis, titled as Granulation of Ready-to-Press Powders using Recycled Tungsten Carbide Cobalt and Simulation of Powder Behavior. So the thesis was conducted as part of VTT's Caramel and Virtual Material Design projects, and the goal was to produce suitable ready-to-press powders for press and sintering applications. And the second part of the thesis was to simulate the powder behavior during mold filling and compaction during pressing using discrete element method. So about the experimental part, 2 different granulation methods were used, so water-based spray drying and high-share mixing. And in total, 10 experimental powder batches were produced, and their properties were compared to 2 commercial reference powders. And as a main outcome, the powders produced by high-share mixing process exhibited the best mold filling and flowing properties, mostly due to the high-density granules produced by this method. Then about the simulation part using discrete element method, where each particle represents an individual element in the simulation. So first, the granule and powder level properties were measured, and they were used to calibrate the model, including flowability, packing, and compression of the powder bed. Then the mold filling and pressing were simulated, and the densification was compared to a real compaction process. And, as a key outcome, through proper calibration, the mold filling process was reliably simulated, but the study really points out the importance of the correct contact model selection and proper calibration methods to get reliable results. Since the thesis has been finished, the scope has been widened for the sintering part. I've been working with scaling up of the high-share mixing process. We're also studying some gradient structures in hard metal components, and I've been further analyzing the DEM model. Once again, thank you for this recognition, and let's have a great conference.
So, the next awardee in the doctorate category is Mr. Zhu, who is research fellow at the National University of Singapore. He obtained his PhD from Delft University of Technology. His research focuses on additive manufacturing of shape memory alloys and multi-material systems. He specializes in process microstructure, property integration, and 4D printing. His work aims to enable high-performance functional components for advanced engineering applications. Unfortunately, Mr. Zhu had an issue with his visa and could not join, but we have his slides.
Good morning, everyone. My name is Jianing Zhu. I completed my PhD at TU Delft. It's a true privilege to be here today, and I would like to express my sincere gratitude to the EPMA for this incredible honor. My thesis focused on laser additive manufacturing of nickel titanium, a process also known as 4D printing. This alloy system is already widely used in the demanding industrial and medical fields. Due to its reversible martensite transformation, nickel titanium have shear memory and superelasticity, allowing for large and recoverable deformation up to 8%. However, the full potential of nickel titanium has been limited by its poor manufacturability using conventional methods. This leads to a central question of my PhD project. Can we harness laser powered by fusion to overcome these fabrication challenges, or reliably produce high-performance next-generation nickel titanium components? Unfortunately, additive manufacturing is not a simple solution. The complex interaction between the laser and nickel titanium powder often lead to the undesirable defects and manufactures. To address these challenges, my research was structured around 3 core pillars: manufacturability, recoverability, and multi-stage functionalities. To achieve high-quality defect-free parts, we developed a novel process map based on defect formation criteria and multiple geometry. This powerful tool enables us to evaluate over 10,000 process parameter combinations under a half hour, just using a standard PC, which accelerates process optimization. To address cracking issue, we employed multi-scale characterization and modeling to understand its mechanisms. Based on this insight, we successfully developed a novel in situ and post-process treatment to inhibit or even heal the cracks in the final parts. To maximum the nickel titanium functional performance, we proposed a novel inverse design framework. This approach, connecting desirable microstructure to its specific processing parameters, results in a high-performance nickel titanium, which capable near 100% recovery stream, even after repeat cycles. Building on this foundation, we developed a method for in situ tailoring of nickel to titanium ratio during the printing. This allows us to fabricate functionally gradient nickel titanium with unique microscale lattice gradients, achieving both shear memory and superelasticity within a single component, which unlocks a new level of functionalities. In summary, laser-powered fusion provides a powerful new possibilities for manufacturing advanced nickel titanium alloys. I believe that further employing the new alloying strategy or process control, we can unlock even more extraordinary properties from this material system. Thank you again for your attention. I wish everyone a success and inspiring Euro PM 2025. Thank you.
So, for the next part, I will call Adeline.
So our next award is a fellowship award. And I'm very glad this year that the fellowship award is for Professor Monica Campos. So please welcome. She is a professor at the University Carlos III of Madrid in Spain, She has 25 years experience in powder metallurgy, focusing in particular on sintering for low alloyed steel and high temperature metals and alloys. She is now also at EPMI, and she has supervised 15 theses so far, so good work. And I'm curious also to hear your viewpoint as a woman in PM. Thank you. Welcome.
Thank you. I'm in shock because I just remember the first European PM conference that I attended. It was 25 years ago in Munich. I attended as a PhD student. I was so nervous. I am today, to be honest. Well, I prepared some words because I want to remember precisely all the people I want to thank this award. Dear colleagues, dear friends, because for me, the PM community is like a big family, and I guess that we build up all together, and we hope in the future that we are continue to this philosophy and this line. It's a great honor to receive this EPM Fellowship Award. I'm very grateful for this recognition. Thanks to the EPM and to the Fellowship Committee for consider my profile for this award. This award is not only for me, but it's also for the people, institutions, and company that has supported my work in this powder technology field over these 25 years. I want to thank to my research group. Some of them are here with me in this session. I want to thank also to my coffee mates. It's like these people who brings energy and joy in the daily days, in the daily work. And in a special way, I want to thank Professor José Manuel Torralba for his mentorships and your guidance over these years. And as a university professor, I consider a privilege not only to advance research, but also to educate and motivate the next generations of engineers and scientists who will continue building this future of powder metallurgy. I hope they engage this commitment as we have been done in this previous year. This award also belongs to my PhD student, past and present, also some of them are here. And also to many graduate and undergraduate students, I have the opportunity to teach and mentor throughout my career. Teaching for me is inseparable from research. I am proud to belong to a community of university professors who see in the classroom the seeds of tomorrow, discoveries and innovation. This award belongs to this group of amazing students. I hope in the future will be some of them here in some of these future European conference. Thank you very much for this recognition.
And now, so thank you, Monica. We go to the Distinguished Service Award, which this year is for Ralph Karlström. Welcome, Ralph. So, Ralph, as you are all aware, has been the president of EPMA for the last 6 years, since 2019. We are very grateful for it. He had to overcome the very challenging period of COVID, which affected massively the resources of EPMA, and he did a number of actions so that the financial health of the association was improved after this difficult period. I would like also to mention some new things started with Ralph at EPMA, which are very valuable. Among them, I would like to mention the campfires, which are informal discussion during the European event. The Sustainability Award also, which is a very important topic. Also a lot of work on statistics, which are important to see where we are and where we go. And also he initiated user-oriented seminars on top of the European conference. So thanks, Ralph, and also personal thanks for the opportunity as well given to me to become a candidate as president for EPMA. Thank you, Ralph.
Thank you. So, good morning, everybody, and thank you very much, Adeline, for this nice word. I would like to thank EPMA, of course, for this award. I'm very proud, and of course, the previous council who selected me. Also need to say thank you, or remembering to the company I work for, Höganäs, for more than 40 years, allowing me to having a lot of fun in this industry. And also been active with EPMA since 2013, when I joined the EuroAM group. And the summary of these last years since 2013 is that it's always been a pleasure to serve EPMA. So thank you very much. Thank you.
So, thank you, ladies, gentlemen. I have to say, it was nice to have Ralph as president for the last 6 years. Looking forward to the next president for another 6 years. Okay, Keynote Paper Awards is one of the last awards of today. So I will call all the awardees, they are already known, because you know which keynote papers are selected. It's sponsored this year by EDP Science. So please, Dr. Mansisidor, Dr. Graves, Dr. Lagos, Dr. Bassini, Dr. Engineer Baumgartner, and Mr. Chang, if you can join on stage.